Okay, let's get started. Since all 80 of you are here, it looks like, so I might as well just start talking about the test. So when's the first midterm? What day is it? The 20th, so that's 2 weeks from today. So just going to tell you, I've already made the test. So what we're going to cover for sure up until that point is everything from the beginning up to the looping slides. So if we do anything else before the first test, that will not be on the first test. So it'll just be everything through the looping slides. I'm pretty sure we'll get through everything on those. So the test will have 5 questions. So all 5 will be programming questions. And there will be questions you have never seen before because no one in the world has ever seen them before. So I like designing questions that have never been asked before, if that doesn't intimidate you. But the point of these questions is to be able to look at a new problem you've never seen before that's actually not that hard to solve and apply the concepts that you've learned to those problems. And we'll go over one type of those types of things later today, probably. So it'll have 5 questions, and they're all worth 25 points each. So I'm not going to ask you anything about like when is a switch statement used, for example. I'm not going to ask you things like that. So it's not going to be like conceptual questions based on like, do you understand where a while loop is used, or where you should use an if-else chain or whatever. So that's not a really interesting thing to ask. A more interesting thing to ask would be, which concept should you use to solve this problem? So if I give you a task to solve, what things should you use? Should you use loops? Should you use if-else statements? Should you use switch? What is a good use of any one of those concepts? But B, can you actually code it up? So can you write a program that actually does the thing that is asked of you to do? So that'll be basically the midterms and the final and how they're structured. But as we get closer, I'll give you more structure as to look at which concepts are going to be more tested than others, because I can't test everything equally, but there will be some things that will be more emphasized than others. Okay, any questions about the midterm or anything else? Yeah. Yeah, so the exam will be on paper, and a good thing you asked that because I forgot to mention this. So the test will have, and I'll mention this closer to the test also, the test will have your name pre-printed on the test. We've had issues in the past where people wrote their name and we couldn't actually read their name or issue ID. So what we decided to do is just have it pre-printed on your test, and they'll be laid out alphabetically by last name. So A's will be in the front, and then it'll go through from there. So it'll be on paper. So it won't be on using any device of any kind other than your brain. Yeah?
So is there any partial credit for code that you write, like for setup?
Yeah. So it won't be like a test case based thing because we just can't do that. So I'm heavy on giving partial credit for things that are really time limited. So like on tests, I give a lot of extra credit for good ideas. So the point of this is to not be able to have an exact solution because that's often infeasible sometimes, but be able to get a good idea about approaching a solution. So what my policy is basically is I give a ton of credit if you even just write your ideas down in English, not even code. Just write your ideas down. That's worth a lot more than just writing a bunch of gibberish code that doesn't do anything. So good ideas are much more important than trying to just write a whole bunch of stuff and in the hopes of getting some points from there. Any other questions about the test? I will talk about more about it later. Yeah.
Are we going to see any of like the formulas like square root that we probably won't see in like the slides, or we won't see them?
You won't need. So the question is, will we encounter things like square root functions or floor or whatever? You won't need them. So everything that will be on the test is a native C++. You don't need any extra functions. But if you know of a function in the C++ library, you can certainly use it if you want to, but you don't, are not required to. Any other questions? Okay, or anything about the assignments, labs, anything like that. Okay, so last time we started talking about these, this new concept of looping. So remember, so what is a loop in general? What does a loop do? Yeah, so that's one way to think of it, is an if-else chain that goes back to the beginning. But more generally, it's just a bunch of a block of code that you can execute more than once. Whereas in an if-else chain or any code we did before, you can only do that code once. Whereas now, with loops, we can go back and do it as many times as we like. So the first loop that we talked about was a while loop, which is really simple. It's while some condition is true, we do the statements inside of the while loop. And then if at any point the condition when it's checked becomes false, then we exit the loop. So if we come back and the condition evaluates to false, we skip the loop and then we're done with the loop at that point. So super simple. So if we come back and the condition evaluates to false, we just continue on after the loop. Nothing special there. So we did this example where we started with 5, val has value 5, and we continued while val has at least 0 value. And then at each point in the loop, we're going to subtract 1 from val, and then when it reaches 0, we'll come through, print 0, subtract 1, val becomes -1, and then the condition now becomes false. -1 is not at least 0, and then we exit the loop. So then we can see when we have 5 here, this loop repeats 6 times. It prints 6 things. Yeah, so if you want to exit a while loop, the condition has to be false at some point. So here are some common loop errors that... I don't know why I did that. Okay. So common loop errors. Did anyone look at this? Putting a semicolon after the while loop statement. What does it do? It makes it into an infinite loop, essentially. Curly braces, we all know why that needs to be there. I'm not sure why the display is darker, but oh well. So what does this one do? In this one where I meant to put double equals instead of just 1? It is an assignment, so what actually happens in this loop? It'll be an infinite loop. So yeah, don't do that. Loop style, we covered this last time. Just make it look nice. Indent the code on the inside of the while loop and align the curly braces so it looks nice. While loops are mainly used for input validation. So while the user hasn't entered a good value, we're just going to keep asking them over and over and over until they eventually, hopefully, put in a good value. And then when they enter a good value, we don't want to ask them. We don't want to ask them again. So then we make that condition evaluates to false. So an example of this is if we want to have the user enter a number between 1 and 100, while the number that was entered is outside of that range, we're going to keep asking you to input until it eventually becomes inside the range, and then this condition evaluates to be false. Okay? So if we enter like 5, for example, both halves of this are false, and false or false evaluates to what? False. So because neither one is true. So then we skip the while loop and then we're done. Then we talked about increment and decrement, which seems unrelated to loops, but it'll turn out to be actually really useful when we get to the next type of loop. So plus plus is the same thing as adding 1 to a value. So a student asked me after the last class this question. Okay, come on, work with me. Maybe make this brighter. Nope, that doesn't work. Okay, so what if we instead did this? So ignore the plus plus. Just look at this statement over here. What does that do? It adds 1 to value, but what happens? So let's just say val before this had value 5. What is it after this statement? Still 5. Because why? Yeah, because we're not assigning back to val. So in fact, this statement does nothing. Okay? So, oops. So, and then if we did this one, we're obviously setting back to val. So if we have some variables on the right side, those are the old values of the variable. So if val has the value 5 from before, then this one on the right side, remember, has value 5. Whereas when we do the plus 1, we're going to be setting 6 to val on the left side. So after this, val will have value 6 because we did the assignment here. But in order to avoid that weird issue, or what if I did that instead? I did 2 equals instead of 1 equal for here. So, well, this is always false, but does that even matter? Are we setting that to something? No, we're not doing an assignment, so what is the value of val after this statement if it was 5 before? It's still 5, because we're not assigning to val. So in order to avoid those 2 pitfalls that you could fall into, plus plus is the way to go. So plus plus just means add 1 to the value and yeah, so just add 1 to the current value held by val. So if it was 5 before, now it's 6. If we did minus minus, if it was 5 before, now it's 4. And then it's the same thing as doing minus 1. So then we talk least favorite part of C++, which is the prefix mode part. So, and postfix. So you could do the plus plus or the minus minus on either side of the variable if you want to, but the issue is if you're doing assignments like this, because if you did the wrong one, you could be assigning the wrong value to the variable x in this case. So and maybe you want the incremented version of y first, or you want the old value of y first. So of course, it depends on what you're trying to do, but it's preferred to be unambiguous here. So what was the solution to avoid both of these issues if I happen to put the wrong one here? Yeah, put the plus plus on its own statement, and then afterward, we assign y, just value y itself to x. So we don't have to worry about, okay, is the prefix one the one we want or the postfix one we want? We just put plus plus before as its own statement, don't assign it to anything, and then afterward we assign y to x. So we don't have any issues like this. And the other reason is that you don't write code like this. Please don't write code like this. I've seen researcher level code where people do this. Don't do this, okay? Yeah, thankfully this one is illegal to do. So you can't, plus plus can be only applied to one variable. It can't be applied to an expression. So you can't do an expression like this and then add 1 onto it because, first of all, what is the plus plus applying to? What are you trying to increment here? It doesn't really make sense there. So it only applies to a variable. You can use them in expressions like this, but again, do you want the plus plus added first or do you want it second? I prefer to just put it on its own line and then use the value that you want instead, just to make it easier. Yeah, so pre and post operations will cause different comparisons. So try to avoid doing that if you can. Okay, so the plus plus, so why do we even talk about this? So a counter is the main reason why. So all a counter is a variable that just counts the number of iterations that are performed. So that's really all it is. All it is initialize a variable to 0 before the loop, and at some point in the loop, add 1 to that variable. That's it. So nothing really special. So let's look at this example here. So let's just say that we want to print the multiplication table. So maybe we're designing an educational application and we want the user to input any number that they want and then put the multiplication table right there. So if you want to know what 7 times 9 is, then you can make the table for that. So, or maybe you want to know like perfect squares, for example. So if we want to know what is 15 squared, for example, the user can enter 15 and then it'll do all that. It'll print all the numbers between 1 and 15. So the user enters the limit and then we print, okay, we're about to show the number square here. So then we initialize some counter right here, this num variable to be 1, because for a table of squares, they usually start at 1. But again, you can assign any starter to this. You can start from 2 or whatever you want. It's not really important what you start at. It's the fact that you start it at some value and then you increment inside the loop. So in this case, we're going to have num be the square that we want to print right now. So num is 1 to start with. So then the perfect square of 1 is 1, obviously. So at that point in the loop, we want to print 1 corresponding with 1. Then the next iteration, we want to print 2 has the square of what? What is the square of 2? 4. So then we want to print 2, 4. And then 3, 9, 4, 16. And then we want to keep going until we reach the input that the user gave. So if the user inputted 15,000, for example, then we want to print 15,000 lines. 1 corresponding with 1, 2, 4, 3, 9, all the way up to 15,225 million. Yeah. So we want to be able to do that sort of thing. So how do we actually do this? So we want to keep going as long as we haven't reached the number that the user actually entered. Okay? So as long as we haven't reached that number, let's do another iteration. So, but do we want an equals right here for the condition? Do we want equals? Yeah, why? Well, so if I enter 15,000, would I be irritated if it stops at 14,999? That would be kind of annoying. So we want to go until we reach the value that was entered. But could it make sense in some other context to remove the equals there? It could be. So, and I invite you to think about like what application that would make sense for. But in this one, it makes sense to have equals. So here, there are actually some things in here that we haven't talked about because we skipped a chapter. Don't worry about this. All this is to print 5 spaces. So set W has something to do with printing the number of spaces to align numbers with. So if we want like numbers aligned nicely, then we would do set W here. But don't worry about what that is. But all we're really doing here is we're printing num. And then at some point later, we're printing the square of num, which is just num times num. And then a new line, you can do \n if you want. And then num++. So the the first iteration, we're going to print 1, and then over here we're going to print 1 again. We're going to add 1 to num, and then we're going to check. Have we reached the limit, or is this condition false? If the condition is still true, we're going to continue through with num equal to 2, and then print 4, and then 3, 9, and then 4, 16, and we keep going until we reach the limit. We print the value that the user entered with its square, and then the next iteration, we're past the limit, and then what actually happens with the condition here? If we're 1 past the limit. The condition's false, and then what happens if the condition's false here? We just get out of it, and then we're done. So, yeah, so let's actually, so if we copy this, I'm going to make a new file because this one has an example I want to run. So let's just say we want to call this squares. Oops. Let's actually copy everything from here over. Remove this because we're going to talk about that later, and then copy this in. And then, okay, so let's G++ our squares file. Oh, okay, I don't have the right headers. So a set W actually requires a header. I'm just going to be lazy and not include the header, just put a space in. So let's do a.out. And then what's an example number you want to go to? What's that? 10. Let's do 10. And then it prints 1, 1, 2, 4, 3, 9, and then all the way up to 10 and 100. And it doesn't do 11 because that's 1 past our limit. If we want to do my example of 15,000, it'll print 15,000 lines. So, and it doesn't go 1 beyond the 1 we expect. What if I entered 0? What would happen? Well, let's actually trace through. I'm entering 0 right here. So what is limit right now? 0. Num is set to 1. So is this condition true or false? False. So what do you think is going to actually be printed? Just this line right here, but nothing inside this loop. And we can actually verify that to be true. So thinking about like what the condition should be is actually really important, because do you want an equals there? Do you want a greater than, less than, not equal, or exactly equal, or anything like that? You got to think about what context. Actually, let's do because we can actually do it now. So in my research and pretty much any mathematics, computer science research, this function comes up all the time. So it's something called the choice function. So you're given an integer n, and you're given an integer k, and you want to compute the quantity n choose k. So what does this actually mean? So think about if we want to, so let's just say I was tasked, so let's just say there are 80 of you here, and my task was to pick 10 of you, any 10 of you that I want. So how many ways can I actually do that? Well, let's just consider this. So let's just say there are 80 people here, and I want to pick 10 of you. Well, how many ways can I pick the first person? The 80 people. There are 80 people to pick. So there are 80 choices to pick. Independent of that first choice, so I remove that person from the pool here, how many people are there left to pick? 79. So is that independent of that first choice, of those 79? Yeah, because once I pick that person, I can pick any 79 that I want. It doesn't depend on what person I picked. So if I pick you or you or you, I'll still have 79 people to pick. So then I have an independent choice to make. So for each one of those 80, I have 79 to pick. So the number of choices that I can pick, let's actually make this easier. Let's just do 2. So if I want to pick 2 people, I have 80 times 79 ways of actually doing that. Okay? let's just say that I pick person A and person B. Let's just say their names are actually A and P. Well, what if instead I picked B then A? Is that really different than if I picked A then B? In some contexts, that might be. But in this context, it doesn't really make sense to talk about the order in which I pick people. So if I pick A then B, that's really the same thing as picking B then picking A. Okay, so that's actually, so for each one of those two possibilities, I only need to pick one of them. So in fact, this number is twice the number of possibilities that I can pick. So in fact, I need to divide by 2 here. Well, think about this in general. So suppose that I have k people that I need to pick. So the number of ways that I can do that is n times n minus 1 times n minus 2 times, and trust me on this, is n minus k plus 1. So that's the number of ways that I can pick k people at all. But for each one of those k, does it matter which order I pick those k people? No, it doesn't matter. Well, how many ways can I order k things? K factorial, k times k minus 1 times k minus 2 times dot 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 times 2 times 1. So in fact, I need to divide by k factorial. And this is actually the same thing that we saw before. So I'm not going to go into exactly why we consider this function all the time, but let's just say we're tasked to actually compute this. So I'm tasked to input an integer n, input an integer k, and then I want to compute this quantity. And a handy way of looking at this is n factorial divided by k factorial and then divide again by n minus k factorial. So it's easier to look at it that way. So if I did 5 choose 2, for example, then 5 factorial, I'll tell you right now, is 120. 3 factorial is 6. 2 factorial is 2. So if we plug this into our formula up here, 5 factorial is 120 divided by 3 factorial, oh, sorry, I did it backwards. 2 factorial, which is the k here, so that's 2, times 5 minus 2 factorial, which is 3 factorial, which is 6. So what is 2 times 6? 12, and then 120 divided by 12 is 10. So in fact, we showed that it really is 10 here. So let's actually figure out how would you actually do this? Well, let's try to think about, well, if I want to know, if we know how to do factorials, can I figure out how to compute the choice and choose k if I know how to do factorials? If I know how to compute, say, n factorial or any number factorial, can I compute n choose k? Yeah, because I'll just do n factorial, save it to a variable, k factorial, save it to a variable, n minus k factorial, save it to a variable, and then do the first one divided by the other two. And then that's all we need to do. So let's actually try to do this. So let's try to compute n factorial. So how would you compute n factorial? So first of all, what does factorial mean? Is n times n minus 1 times n minus 2 times dot 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 times 2 times 1. What concept that we just went over would be really useful for this? Ah, the counter, or a decrement. That could work too. So let's actually do this. So let's just say we have a product variable set to, well, what should I set the product variable to, the thing that's going to hold n factorial at some point? What should I initially set it to? There are multiple answers here. Should I set it to 0? Well, what if I did 0 times 1 times 2 times 3 times dot 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 times n? What would that be? 0. Would that help me? No. What should I set it to? 1 would be a good choice. Because if I happen to do 1 factorial, then I better get the result of 1, because it's just 1 times 1. Okay, well, I need the counter variable, and what should that start at? Well, it depends on how we actually construct the loop. So what we want is something that looks like this. While some condition, we're going to multiply prod times the counter variable. So let's just say we have a counter initialized to something that we're going to talk about in a second. And then we're going to counter plus plus here. So so the first iteration counter should be something like 1, then the next iteration should be 2, 3, 4, ... up to n. Well, let's see. What should counter start at then? What would be a good way to start here? So there are 2 choices here. We could start at 1 and work our way up, or we can start from the number we input in and work our way down. Either way is okay. I'm going to start from the bottom up. So the counter, I'm going to initialize to 1 because the product, I want it to multiply by 1 first, then 2, then 3, then 4, up to n. Well, let's see. The counter is going to start at 1 and go up, up, up. At what point should I stop? So let's think about this. So do I want to do something like this? Well, let's think. What is the last iteration value of counter here? 1 less than n. Do I want 1 more iteration? Yeah, because we want 1 times 2 times 3 times ... times n minus 1 times n. So we actually want an equals right here. Because we want it to go through n, because I want to multiply by n at that point. So, and then, in fact, this is all we need to do. So if we trace through this, then the counter is 1 the first time through, then incremented. Second time through, it's going to be 2, so we're going to multiply by 2. Next iteration is going to be 3. Next iteration is going to be 4, until we reach n, and then we multiply by n. Next iteration is n plus 1, but that is too far, and then the loop will exit. So let's actually verify this. Let's actually see out the product at the result. So if we enter 5, what should we expect to be printed here? 120 from before. So let's actually g++ our main file. So if we enter 5, I enter k here, but we haven't used k yet. So this is just a useless input now. And then we print 120. So if we wanted to do 6, this should print 720, and it does. So it's multiplying 1 times 2 times 3 times ... up to 6. Yeah. What's that? So product is supposed to be the factorial of n. So in fact, so is prod a good name for this? No. Why? It's really in general, but why in this specific case is it a bad idea? Because we're going to do this 2 more times, right? We should have 3 prod variables, right? So 1 for n, 1 for k, and 1 for n minus k. So what I'm going to do instead is I'm going to call this n factorial. And then, so this is a much better name because it actually makes sense. Well, is this code almost identical to what we need for k factorial and n minus k factorial? Yeah. In fact, all we need to do is copy and paste this. So copy and paste. So I'm going to make one for k factorial and then have the k factorial here. What should the counter be for here? It should be k in this case. In fact, there's actually going to be an error on this line. Can you tell me why? I'm reinitializing counter. But I don't need counter, 3 different counters here. I only need 1. So I'm just going to reinitialize it to 1 to make my life easy. But if you were smart, you would do something different. Let's just say that we're going to have an n minus k factorial variable here, and then copy it down. And then what should the condition be here for n minus k factorial? N minus k. So then now we need to figure out what is n choose k. So I'm just going to copy this down here. So if I want to know what n choose k is, I'm going to make a variable for it. So I'll tell you right now that it'll always be an integer, so we don't have to worry about integer division here. So let's just say that n choose k is the variable that I want, and then how do I compute this on the right side? Yeah, it's basically literally just copy and paste this down. So I'm going to make n factorial on the top divided by, with parentheses here, because I want to put k factorial and n minus k factorial on the bottom here. So then I want k factorial downstairs, and then also n minus k factorial down here. And then all we do is print n choose k. Oops, not namespace, n choose k. So let's actually run this. So if I run this with 5 and 2, what should I expect? 10. So let's actually verify that that's the case. 5 choose 2 is 10. Pretty cool. So what appears a little annoying about this, though? Is there something really, really, really similar between these 3? It's almost identical, right? But so what we're going to do in the next set of slides is be able to say, okay, if we're doing this a bunch of times, let's hoist all of that all the way into one place, and then we only have to modify it in one place if we need to make a modification. So it's a little annoying here, but could we actually do it? That's what I'm asking. Could we actually do this? Yeah, because n choose k is just decomposing the problem into 3 subparts. One to compute the factorial of one thing, and then the other thing. So then by decomposing this one task that we need to do into 3 parts, and all 3 parts have the same flavor to them, namely computing the factorial of something, all this text boils down to is, can we actually compute the factorial of something? And in fact, we can, because we have counters now. We have counter variables. So we start them at 1, or as was suggested, you can start from the number that was entered and work your way down. That's fine too. But the way that I'm doing it here is you start at 1 and then multiply by that number going up until you reach the number that you desire, which is n or k or n minus k here. And then all you do at each point is do the calculation at each step in the at each point with respect to the counter. And we know that n factorial is 1 times 2 times dot 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 up to n. So we just have a counter that works from 1 to n and multiply by each point along the way. I'll post this code on as an announcement so you can play with it if you want. But any questions on how we actually were able to solve this? So I'm going to tell you right now, the test will have easy questions, and then it'll have 1 or 2 questions along this line of difficulty. Maybe not that much code, but along that line of thinking. You have to solve this problem and break it down into multiple pieces. Okay? Just letting you know right now. But any questions on the example? Yeah.
I don't understand how your factorial is calculated, because I would think that it's like you get a value, then you multiply it by your value minus minus. You set your counter to like how many operations there are for the calculation?
So the counter is actually serving two purposes here. It's serving to tell you which loop iteration you want, but we can use it also in part of the factorial calculation. So if we look here, let's just say we wanted to look at 5 factorial. Well, that is just 5 times 4 times 3 times 2 times 1, right? No issue there. So let's actually step through this. Let's just say that n really was 5 here, and we inputted 5. So counter initially has value what? 1, because we set it to 1. N has value 5. Is 1 less than or equal to 5? Yeah, so then we enter the loop here. So then, what is n factorial right now? 1, because we haven't changed it yet. So 1 over here, 1 for the counter. So 1 times 1 is 1. I know it's early. So then n factorial is going to be set the value 1. So we really didn't do anything. So then counter plus plus, what happens there? It goes to 2. So then we go back. Is 2 less than or equal to 5? Yeah. So then we enter the loop again. So n factorial right now is still 1. What is counter now? 2. So then n factorial now will be 2. Good. So n factorial is now 2. Counter will be up to what value? 3. Is 3 less than or equal to 5? Yeah. N factorial right now is? N factorial is 2. What is counter? 3. So what is factorial going to be? 6, because 2 times 3 is 6. Then counter will now be 4. Is 4 less than or equal to 5? Yeah. So n factorial right now is 6. Counter right now is 4. 6 times 4 is? So n factorial now will have value 24. Counter goes up to what value? 5. Is 5 less than or equal to 5? Yes. So then we go through again. N factorial has value 24. Counter has value 5. So 24 times 5 is 120. So n factorial now has value 120. Counter goes up to 6. Is 6 less than or equal to 5? No. So then what happens? It exits the loop. So at each point, we're going, in this computation right here, we're going from the right to the left. Okay? So we start the counter over here, and then multiply by each one of these numbers in turn until we reach here, and then the next iteration we guarantee to exit the loop. Any other questions about the example? Yeah, I can't tell you how many times I've used this function. So it's actually pretty well used. So a counter for a loop. But the counter, as we just saw, can be used for other purposes, like multiplying by a number. But another use of it can actually be, instead of multiplying by the counter, you can add with the counter variable. So if I have if I want to know the sum of numbers between 0 and 10 or whatever, then I want to know what 0 plus 1 plus 2 plus 3 plus ... plus 10 is. So we can use something along the same lines. But we have to think a little harder here. So let's think about before even the loop occurs. If we've added 0 numbers so far, what is the current sum? If we've added nothing so far, what is the sum? 0. So that's why the sum is initialized to 0 here, whereas the product before, in our example, was set to 1. Because if we set 0 to the product before, the 0 times anything is still 0, so we don't get the result we want. Whereas for sum, it actually makes sense to start at 0. then we set num to 1 here. I'll revisit that in a second. So while num is less than or equal to 10, we add num onto the sum. So plus equals, have we covered plus equals before? Okay. Is another shorthand. And I'm not sure why it's not here, but the way that so sum plus equals num is the same thing as doing this. So all it is take the value of sum and add num to it. So the plus plus and minus minus that we have been talking about before is just the special case of when num is equal to 1 or minus 1. But if we have something other than 1 or minus 1, then if you want to do the shorthand, you can do this. So if we wanted to add 5 onto sum, I can either do it this way, which is take the old value of sum, add 5 onto it, and then store it back in, or you can do this. Either one is okay. It's just a shorthand for the second one. This again. So this line right here is looking at adding the value of the variable, that the counter variable, onto the current sum, and then we add 1 onto num at each point in the computation. So then once we get to 10, we add 10. Num is incremented to 11. And then we go through and we see, oh, the condition's false now, so we exit the loop. And so therefore, we're adding 1 the first time around, then 2 the second time, then 3 the third time, then 4, then 5, then 6, then 7, then 8, then 9, then 10, and we don't go through on 11. So then we really are adding 1 through 10 onto the sum variable, and then this will print 55, which is the sum between 1 and 10. Question for you, what if I started num at 0? Would that be okay here? Yes. So adding 0 onto anything is the whatever it was before. So if we add 0 here, it actually doesn't make a difference. So they just start 1 here because we don't want to go through the loop an additional time if we don't want to, if we don't have to. But it turns out there's no difference in the actual value that is outputted. Okay. So any questions on this? So this is something called an accumulator or a sum variable. So you're just accumulating various things. What if I wanted to know, instead of all the numbers between 1 and 10, I want to know the sum of the odd numbers. So like 1, 3, 5, 7, and 9, instead of including the even ones. How would I change this example? Yeah, so instead what I would change this line to be num plus equals 2, or num equals num plus 2. Either way is okay. So if I wanted to do odd, that's the only change I have to make. Do I need to change the 1 up here? No, because it starts as 1, and I want the odd numbers anyway. So we have no issue here, which is pretty cool. Yeah, so if I wanted even, once we have the plus equals 2 downstairs, we would change this to be 0. Any questions about running totals or accumulators?
You multiply the numbers, even numbers, you just start at 2.
Then I would start at 2, and I would start this variable at 1 because 0 times anything is 0. Yeah, so if I wanted to do product of evens, then I would start this at, actually this one I would start at 1. Because 1 times anything doesn't do anything anyway, so I'm not worried about that. But if we do the plus equals 2, yeah, you would want to start at 2 here. Okay, I'll be super generous and give you 17 seconds, so I'll see you all on Friday.